That day we learned about rate. Let's have a quick recap of what is rate of a reaction. Rate of a reaction is change in concentration upon change in time. We also studied there were two types of rates. One was average rate, the second was instantaneous. Average rate was denoted by delta, that is, when the time difference is large we use average rate, and for a small interval of time we use instantaneous rate, that is, we use t is time, right? So when are we going to use average rate? We are not going to use this in this chapter. Why? Because average rate indicates the rate of the reaction from the starting to the beginning. But when we are studying mechanism is how the reaction is happening, what factors are affecting the rate of the reaction. So we have to study all the minute detail. For that we use instantaneous rate. Again, for another example, let's take the formation of SO3 molecule. So let's write the reaction. SO2 plus O2 gives you SO3. To balance it, let's write the rate expression for this reaction. R is equal to minus 1 upon 2 d SO2 by dt, which is also equal to minus, there is just 1, so 1 upon 1, that is equal to 1 d of O2 by dt, which is also equal to 1 upon 2 change in concentration of SO3 upon dt. So here the first part of the chapter, that is rate and its definition, or I can say rate expression, ends. Now the next part of the chapter is rate law. Now before coming to rate law, we all know that a reaction takes place under certain specific condition only, and with the change in time we see there's lots of things changing in the reaction. So this rate law is something which is experimentally determined, and it says, or it states, the relation between rate and concentration of the reactant. The most important factor in a particular reaction is the concentration of the reactant, right? Because without the reactant the reaction won't proceed, or reaction won't start. Changing the conditions of the reaction will change the product, but initially let us focus on concentration of reactant. In chemical equilibrium, according to law of mass action, we have studied that rate is directly proportional to the concentration of reactant raised to their stoichiometric coefficient. Or like, for example, we have just studied this AA. If the reaction is AA plus BB gives you CC plus DD. We studied rate for the forward reaction. A and B are the reactant, and for the back reverse reaction, C and D are the reactant. So for the forward reaction, rate will be directly proportional to concentration of A raised to A and concentration of B raised to B. And for the reverse reaction, we had rate is directly proportional to concentration of C raised to C and concentration of D raised to D. Do you remember this thing? But this is when there is a reversible sign, means this will be applicable for a reversible reaction, not for a irreversible reaction. So let us see rate of an irreversible reaction. So according to rate law, again rate is directly proportional to the concentration of the reactant raised to some power x. Now let us understand what is this x. X, where x is known as order of the reaction. Now what is this order? Before coming to that, let us derive the same thing for a given reaction. Let's say, for example, let's take the same example. AA plus BB gives you CC plus DD. Okay. let's not take a reversible reaction, let's take an irreversible reaction. Here's your Cc plus Dd. Now we know that here only A and B are reactant, the C and D are product. Okay, so according to the rate law, rate will be directly proportional to the concentration of A raised to X. Since there are two variables, that is P is also there, you can also take rate is also directly proportional to B raised to Y, and therefore rate will be proportional to A raised to X, B raised to Y. And we have been doing this to remove a proportionality sign, we always add a constant. Therefore rate will be equal to K A raised to X and B raised to Y. Now what is this K? Here K is known as rate constant, which will be given by K will be equal to R upon A raised to X and B raised to Y. Is this clear? Now again a quick revision. What will be the unit? What do you guess will be the unit of R? Since R is rate is change in concentration upon change in time, its unit should be moles per time. Okay, so instead of writing moles per time, we read moles second inverse. That's unit of rate. Accordingly we have a unit of K. Now the unit of K depends upon the value of X and Y. Let us understand here now what is X. This expression, what expression we derive, R is equal to K A raised to X and B raised to Y, is known as rate law. This expression gives you a relation between the rate and the concentration, and also how the concentration of the rate, how the concentration of the reactant will affect the rate of the reaction. Okay, let us understand now X and Y. Now X here is known as order with respect to A, that is concentration of A. Y is known as order with respect to concentration of B, and X plus Y is known as total order of the reaction. It is very important to note that unlike in chemical equilibrium, instead of this X we used to write this stoichiometric coefficient, that is A and B. So let me tell you, A plus B is actually known as molecularity of the reaction. Now what is the molecularity of the reaction? What do you mean by molecularity? Molecularity means the number of molecules of the reactant taking place in the reaction. Okay, like for example, for this reaction, if there's 3A and 2B, so the total molecularity will be 5. It is very important to note that X plus Y may or may not equal to A plus B. Did you get it? No, maybe. A plus B is known as molecularity, X plus Y is order. They are two different terms. When are, just as I said, they may or may not be equal, and I'm also saying that order and molecularity are two different things. So let us see when are they going to be the equal. So first of all, we have to understand types of reactions. Okay, there are many types of reaction. Mostly if I say formation of NaCl, so we just write Na2Na plus Cl2 gives you NaCl, right? Now if you know this is the reaction, but this reaction involves multiple steps. Like the formation of NaCl takes place in n number of steps, not just directly you take sodium and chlorine. Okay, it occurs in the following step. Like for example, the first you heat the sodium, that is the sodium is there, it get sublimated, that is sodium gets converted into gaseous state. Chlorine Cl2 gets converted into atomic state, it's known as atomization. Okay, then sodium gaseous atom loses one electron to give you Na plus. This one electron is gained by Cl molecule, that is Cl atom, to give you Cl minus, and then this Na plus Cl minus gives you NaCl. Right. So this whole reaction, this reaction is happening in this number of steps. Right. So such reactions are known as compound reactions or multiple step reaction. Compound reaction or multiple step reaction. But however, there are many reactions which occurs only in a single step. Okay, only directly in a single step. Okay, such reactions which occurs only in single step are known as elementary reaction or single step reaction, or maybe most of the time we assume that this plus this will give you that, right? So it is also known as hypothetical reaction. When nothing is mentioned, when hypothetically mentioned, you have to assume that it's a simple reaction. Okay, and in such reaction, in a elementary or single step reaction, hypothetical or simple reaction, you will find that x plus y will be equal to a plus b. Okay, you have learned a condition in logic that there's something known as IFF, if and only if, double implication. What is this double implication? If it is a single step reaction, then order will be equal to molecularity, or this is applicable vice versa, that is, if order is equal to molecularity, it is a single step reaction. You have to understand, this has to be noted. For complex reaction, we'll come later how and what is the order of the reaction, how it is determined. To know that, firstly we should know what is order. I know you still have question, what is this order, what is this x and y? So let us understand the order of the reaction. Okay, now this can be given by a very simple example. Another same reaction we take, AA plus BB gives you CC plus DD. Let's say my initial concentration is A1, B1. We won't take concentration of product because the rate law says that the rate of the reaction is directly proportional to the concentration of the reactant raised to some power x, right? So the concentration of the product does not matter here. And let the final concentration be A2 and B2. Let's take value. Suppose A1 is 10 moles. Let's take B2 as again 10 moles, A2 as 20 moles, B2 as 10 moles. Okay, capital M. And we also take a condition, A3 as 10 moles and B3 as 20 moles. Now when I'm saying rate law, it is like we are doing an experiment in a particular lab. We are finding out, like for example, for this reaction, initially I took the concentration of A as 10 moles and concentration of B 10 moles studied, and I found out that the rate was found to be, let's say example, 2 moles per second at this condition. Let this be R1. Okay, similarly it was experimentally determined that R2 is equal to 4 moles per second. That is when the condition A2 was 20 moles and B2 was 10 moles. And for this condition, that is A3 was 10 moles and B3 was 10 moles, R3 was found to be 8 moles per second. Right. So now from this condition, I am going to derive and explain what is order of a reaction. You have to this you can, if you have a book, you can note down the condition so that in the further video you can refer to it. Condition A1 is 10 moles, B1 is 10 mole, A2 is 20 moles, B2 is 10 mole, and A3 is 10 mole, B3 is 20 moles, R1, 2. So let's take condition 1 and condition 2. Now remember what was condition 1? Concentration of A1 is 10 moles, B1 is 10 moles. Okay, R1 was found to be 2. Similarly, condition 2 was A2 is 20 moles, B2 remains as 10 moles, and R2 then was found to be 4 moles per second. Right, I use this condition, write the equation. What is R1? R1 will be equal to k a1 raised to x and b1 raised to y, and R2 will be k a2 raised to x and b2 raised to y. It is very important to know that k is a rate constant, and that is why you see it is not changing. You can see R1, R2, that is, this is variable, this is also variable, and this is also variable, but k is constant and won't change. Now let's simply divide R1 by R2. You can also take R2 by R1, it depends on your convenience, right? I just divide R1 by R2 by putting the values of the respective term. Okay, so R1 was 2, R2 was 4, k as it is gets cancelled. This a1 raised to x, so the concentration of a is 10 raised to x. For b, again it will be 10 raised to x, but a2 is 21, so it is 20 raised to x, and this will be also 10, this will be y, so 10 raised to y. This gets cancelled, this is 1, 2, and this is also 1 and 2. Remember, this is x remains there, so it becomes 2 raised to x. It's very simple. So from this I get 2 is equal to 2 raised to x, and it's very easy to guess that x will be equal to 1 because 2 is equal to 2 raised to 1, right? So from this condition I derive y. How do I know that I'll get x from this condition? As just simple, if you see very clearly, the concentration of A changes, the concentration of B remains constant. In simple term, if I say x, how would I define x, or how would I know what is x? In simple term, I can say x will show you that the magnitude of effect that the change in the concentration of A will bring on the rate. Oh, this is too much English. In simple term, what we can say is A change करने पे, A के concentration को change करने पे rate कितना change होगा. I know यहाँ पे if you see it is being doubled, the concentration of A doubles, the rate also doubles, so x will be 1. It's very simple. That's how it is. It's like, इसका मतलब है x का मतलब क्या, x that is order with respect to a. order with respect to a का मतलब होगा आप a के concentration को change करोगे तो rate में कितने times changes होगा, rate में कितने time changes होगा. Like for example, if you see here, आप ध्यान से देखोगे तो a double हुआ तो rate भी double हुआ, right? That means कितने टाइम दोनों में चेंज हुआ, ये भी टू टाइम्स चेंज हुआ, वो भी 2 times चेंज हुआ. दैट इज रिलेशन इज 1. लेट्स अंडरस्टैंड मोर विद रिस्पेक्ट टू y also. Okay, so first condition and third condition. First condition was concentration of A is 10, concentration of B is 10, rate was found to be 2 moles per second. The third condition was, this is A1, B1. The third condition was A3 is equal to 10 moles and B3 is equal to 20 moles. Now if you see clearly here, the concentration of A remains constant, the concentration of B is double. Okay, and the rate becomes how many times, right? So that will give you the relation, that is y, the order with respect to B. So let's take, in this case, let's take R3 by R1. Okay, earlier we took R1 by R2, so here it is up to you. You can take R1 by R3 also. So I'm just putting the value directly since we already know the equation. What are R3? Let's write the equation also. Check. R3 is equal to K A3 raised to X and B3 raised to Y divided by R1, which is K A1 raised to X and B1 raised to Y. I can cancel K here itself. What is R3? What is the value of R3? We know it's 8 upon R1, which is 2. A3 is 10 raised to X. B3 is 20 raised to Y. A1 was 10 raised to X and this is 10 raised to Y. This gets cancelled 4, right? This also gets cancelled and this becomes 2 raised to Y. So here I get that 4 is equal to 2 raised to Y, that is 2 is equal to 2 raised to Y is equal to 2 raised to 2, that means Y is equal to 2. It's very simple to get this, right? Now what do you conclude from this? I conclude that like इससे ये पता चलता है, if you double the concentration of B, आपने B के concentration को double किया, rate कितने टाइम इंक्रीज हुआ? So if you see, it's almost going to cube type, 2 to 8, right? So this, the factor by which the rate of the reaction increases when you change the concentration of B is 2. मतलब B के concentration को change करने से rate कौन से factor से change होगा? That is order with respect to Y. Order with respect to B, which is Y. Now, so from this I conclude that R will be equal to, this is general equation, that is rate law, R will be equal to K A raised to 1 and B raised to 2, and the total order of the reaction, okay, 1 was order with respect to A, 2 was order with respect to B, so order of the reaction is 1 plus 2, which is equal to 3. So that is how you're going to determine the order of the reaction. Now, you cannot determine the order of the reaction by seeing the reaction itself. Okay, you need to know conditions. Okay, the most important condition is experimental condition. Like the conditions will be given to you. You use the condition and derive the value of x and y, just like how we derived. Okay. Yeah, if the question says that this reaction is a first order reaction, you have to assume that it is a first order reaction. Now, let's classify reaction on the basis of order. Okay, so let's first say for a reaction, if x plus y is equal to 1, the reaction will be known as first order reaction. So henceforth, आगे से अगर मैं बोलता हूँ first order reaction, you have to assume that x plus y, that total order of the reaction. Okay, there can be x plus y plus z also, or only x. Okay, the total order of the reaction is 1. This is known as first order reaction. If the total order is 2, it is known as second order reaction. Yeah, you're ready to guess. If 3, it is third order. 4, it is fourth order. But order can be 0. Yeah, it can be 0 also. Order can be 0. It can be first order. It can be second order. It can also be fractions. Order fraction भी हो सकता है, but it cannot be negative. Order cannot be negative. Question is क्यों नहीं होता है? So if I say rate law is a raised to a. Rate is directly proportional to a raised to x. If I write it as negative x, it becomes inversely proportional, which is against rate law, right? So this is not possible. So you have to remember, order can be 0, first, second. It can be fractions also, but it cannot be negative. The question is, how can order be 0, right? So reaction in which the rate, that is the speed of the reaction, does not depend upon concentration of the reactant. मतलब आपने reactant कितना लिया है उससे फ़र्क नहीं पड़ता, speed उतनी ही होगी of the reaction. That is known as zero order reaction. So a zero order reaction will be a reaction in which the rate is independent of the concentration of the reactant. Rate is independent of the concentration of the reactant. Okay, first order reaction is when the total order is 1. Now it can be half plus half, or it can be 1 plus 0, or whatever it can be. Okay, is this clear? Now let us take another example to derive the order of the reaction. I know one example is not sufficient, right? So for this I won't give you numerical value. I'll give you direct how many times it doubles. And like for I can say, when no condition is given, the initial condition is assumed to be like R1 is equal to A raised to X and B raised to Y. It is to be assumed, right? So if I give you that, this condition is mentioned. For a reaction, again A plus B gives you products. We really don't care what is the product here, because again we focus on A and B, that is the reactant only. The condition mentions that when the concentration of A was doubled, when the concentration of A was doubled, rate increased by a factor of say by a factor of 8. By factor of 8 means rate increased 8 times. Okay, it also says that when the concentration of A and B, sorry, let's take this thing only with B. When the concentration of B is doubled, or I can say triple, the rate of the reaction also triples. I repeat the condition once again. When the concentration of A was double, A के concentration को double किया तो rate 8 गुना बढ़ा by the factor of 8, और जब concentration of B को हमने triple किया तो rate भी triple हुआ. Now there are two ways to work out this formula. Now this आप इसको डायरेक्ट भी सॉल्व कर सकते हो और फॉर्मूला वाइज जिस तरह हम लोग ने प्रीवियस इक्वेशन सॉल्व किया, यू कैन सॉल्व बाय द प्रीवियस मेथड ऑल्सो. इफ दिस क्वेश्चन कम्स फॉर बोर्ड एग्जाम, वी आर यूजिंग द लॉन्ग मेथड लाइक द प्रीवियस how we solved previous example, right? But if this comes for CET or JEE or for NEET, or you want to check your answer at the end, you can just simply use this equation what I'm giving you a formula. This is not allowed in HSC. This is just a formula to check your answer or to write the answer for the MCQ, because for MCQ we have only 1 minute, so we don't waste writing all those things. See, according to rate law, I know rate is directly proportional to concentration of A raised to X, and rate is also directly proportional to concentration of B raised to Y. In the first case, they have changed the concentration of A. उन्होंने A के concentration को change किया, rate change हुआ. Second condition में उन्होंने B के concentration को change किया. Let's use this condition directly. क्या बोला है फर्स्ट केस में? रेट इज डायरेक्टली प्रोपोर्शनल टू A रेज़ टू X, राइट? सो कॉन्सेंट्रेशन ऑफ A को डबल किया. मैंने A के कॉन्सेंट्रेशन को क्या कर दिया? डबल. डबल का मतलब होता है 2 इंटू A, राइट? 2 इंटू A रेज़ टू X. ओके, A नहीं लिखूंगा मैं, सिर्फ डबल लिख दिया उसको, राइट? सो एंड तभी रेट क्या हुआ? सो रेट इंक्रीज बाय फैक्टर ऑफ 8, मतलब रेट हो गया 8. Okay, you can use this. So what is 8 is equal to 2 raised to X? Can you guess what is X? X will be equal to 3. Simple. Right, let's do for B. B के concentration को आपने ट्रिपल किया, रेट भी ट्रिपल हो गया. मैं यहाँ पे डायरेक्ट लिख रहा हूँ कितने टाइम से आपने मल्टीप्लाई किया. So Y becomes equal to 1. Now using the same method like we did what we did for the previous question, I'm just going to derive that X is equal to 3 and Y is equal to 1, and the order will be 3 plus 1, which is equal to 4. So this is like 30-second methods, or you can directly do in air if you're comfortable. Afterwards, this will happen with practice. This is we are going to use for MCQ, for JEE, NEET, CET, whatever. Okay, and this has to be marked in your book. Now I'm just using the long method, that is HSC method, to derive that X is equal to, which was 3 and Y was equal to 1. So let's take condition 1, that is R1 is equal to K A1 raised to X and B1 raised to Y divided by R2, which is K A2 raised to X and B2 raised to Y. Now you may say, sir, value तो दिया नहीं है. Value is not given, but we have given कितने टाइम बढ़ रहा है, right? So let's take R1 as R1. R2 is क्या होगा? R2 क्या होगा? उसने बोला है when the concentration of A was doubled. तो इनिशियली कुछ तो था, वो जो इनिशियली है उसको A1 लेते हैं, फिर बाद में जो हुआ उसको A2 लेंगे. So this is R1, A1, B1 is given to us. This first condition is actually A2 and R2. B के बारे में मेंशन ही नहीं किया है, मतलब B कांस्टेंट रख रहे हैं वो लोग. ओके, सो R2 increases by a factor of 8, so it will be 8 into R1. Okay, K and K gets cancelled itself. A1 क्या बोला था उन्होंने? कुछ नहीं, right? They don't have the value, so we'll keep as a1 raised to x and b1 raised to y. But a2 के लिए क्या बोला उसने कि the concentration double, the concentration of a double, so I'll write 2 into x, a1 raised to x. You have to understand that if I have a1 raised to x, okay, and when I'm multiplying it by factor, the x gets multiplied to that factor also. So it is 2 raised to x, a1 raised to x, and b1 does not change, तो b1 को वैसे ही रखा है. If they have not mentioned anything about b, मतलब उसको क्या किया है, constant किया है. ओके, प्रीवियस टर्म में बोल दिया था a1 was b1 10 है, b2 भी 10 है, it means the same thing. So I get this gets cancelled, this gets cancelled, this gets cancelled. So you have 8 is equal to 2 raised to x. Therefore x is equal to 3. Simple, what we got, right? Similarly, if you take condition 1 and 3, that is r1 upon r3 is equal to k upon k, a1 raised to x and b1 raised to y, and a3 raised to x and b3 raised to y. If you remember, आपको याद रहेगा तो ए के कॉन्सेंट्रेशन को चेंज नहीं किया था, दे ट्रिपल द कॉन्सेंट्रेशन ऑफ बी एंड द रेट ट्रिपल्ड. सो r1 अपॉन ट्रिपल हुआ, मतलब 3r3. ओके, के कैंसल, they did not change, they did not mention anything about a, so a का concentration remains constant. Okay, b में b1 will be b1 and b3 will be 3 raised to y, b3 raised to y. Okay, this gets cancelled. I guess it's pretty simple now. 3 is equal to 3 raised to y, y is equal to 1. Okay, so this is what we derived earlier, x is equal to 3 and y is equal to 1. Okay, so in short, what is order? Order से आपको क्या पता चलेगा? Order से आपको पता चलेगा कि concentration, reactant के concentration को change करने से rate कितने times बढ़ेगा. Okay, so this concludes what is order of the reaction. On the basis of order, reactions can be classified as zero order, first order, second order, third order. It can be half order also, but order cannot be negative. Okay, and molecularity, what was molecularity? Molecularity is number of molecules of reactant taking place in the reaction. When is order going to be equal to molecularity? When the reaction is single step or simple reaction. Thank you.